Next, we have Dianne Chong, who will discuss design and manufacturing challenges for future aerospace vehicle structures that will be driven by the improved understanding of the current and emerging systems. Dr. Chong is Vice President of Materials, Manufacturing Structures, and Support in the Boeing Engineering Operations and Technology Organization. In this position, she leads the organization responsible for development and support of manufacturing processes and program integration for the Boeing enterprise. She is currently serving on the NAS board on global science and technology and is a commissioner to the Accreditation Board for Engineering and Technology. Dr. Chong.
Thank you. First of all, let me tell you that it's a tremendous honor and pleasure to be at this forum. I spoke here a few years ago on the 787 program, so I hope you're not disappointed. I'm not going to focus just on that program, but I will allude to it. So the first chart begins to show some of the challenges that we face in any aerospace company. We have multiple platforms, as you can see. So how do we best accommodate manufacturing technologies to accommodate all these different types of products? You can see everything from commercial airplanes that everybody understands or associates with the Boeing name, but we also are in the business of producing military products, both fighter aircraft, rotorcraft, future products, that some of the fixed wing body products that you see there, and some of the innovative structures, as well as space products as well. And the space products aren't just the usual space launch vehicles that you think of, but we're also in the missile defense industry as well. So how do you really accommodate manufacturing of all of these products? And our role in manufacturing of these products is not to make every single part that goes on these products. And that's a challenge for us as well. We choose to make certain of these parts ourselves for each of the products. And some of the parts we either partner with others or outsource to many others. And standard parts, we have many suppliers supplying to us. 60% of our products are outsourced or produced by, or the parts that we use are produced by suppliers that actually supply these to us. And they are very global in nature. So we've made a lot of advancements in materials and the architectures as shown, and I like some of the charts that were shown earlier today. This is what it used to be. It shows an example, and as we evolved over time, we've made advancements both in the metals, non-metallics, the materials areas, as well as improvements in understanding how to design our products better, understanding how to increase the functionality and the architectures, and utilizing the technologies that are available to all of us. Inclusive in this is also the manufacturing technologies. Have we kept up with those as much as we should? And I would say that at one point in time, we did not do that as well as we are doing today. We relied on the materials, we looked at the fabrication, but we probably did not look in the past at advancements in automation the way that we needed to do, but we have caught up significantly over the last few years. I spoke a lot about the 787 last time. This is a great example of how the composites materials have driven a lot of the manufacturing technologies that we have advanced in. You cannot look just at the materials systems by themselves, but you have to look at how you actually fabricate and then assemble these things together, and this drives the other material systems on the airplane as well, or on the various products that we use, because of the interface concerns between the different materials. Some of the advancements that we're looking at now are what are the next generation of material systems that we should be investigating. What are the things that can eliminate the autoclave and improve the productivity and the flow through the plant for our different parts, different material systems, how can we combine those better? And this is a challenge for us because, again, we rely a lot on our suppliers and partners to work with us on this, because we don't produce resins ourselves or the reinforcements. We rely heavily on suppliers for that innovation, but we help them with the advancements and by providing the requirements. Same, we're looking also at advanced thermoplastics for many of our systems, and how to prevent microcracking for space systems as well. As I said, we have a variety of products with different requirements. In addition to this, where many of our military systems and our space systems require very high temperature systems, in addition to the ambient system, relatively ambient systems that a regular commercial airplane requires. And then as with anything else, in joining these materials, what are the right adhesives? So we relied on the chemical industry. As I said before, we rely on a lot of processes to help us form parts as well as join them together. And there's a lot of lamination systems as well as advanced forming systems that we have to use. We look at bonding systems, co-bonding systems. How can we do this? Big area is repair technologies, because as we deliver the products, and earlier today people talked about manufacturing and services, there's a huge service industry even after the product is delivered, where we help and provide technologies for the maintenance of our products after they are delivered. And certainly repair is a tremendous area in the composite areas. It's relatively understood in the metals area, but there's a lot yet to learn. And it is something that we consider under manufacturing. We look at advanced tooling as well, and what can be provided, what are the things that are needed in order to survive the multiple cycles that we have to undergo with these materials, as well as more sophisticated and quicker inspection systems that can be used with large monolithic parts. Design and certification is something where we have developed a lot of tools with the help of some of the other people who have been presenting today, to help us predict flaws, understand the materials, and how they can be used, and so that we can better design to their capabilities. Another area that can't be neglected is the metals area. It's very important to us. When I talked about the 787 earlier, people always assume they call it the composite airplane. It's 50% composite, which means that 50% is other materials, including a lot of metals, as well as the other chemical materials that are on that airplane. In looking at what we need to do in the metals area, we are engaged in investigating new alloys, new ways of forming metals, including additive manufacturing. I was very pleased it was mentioned this morning, because we are looking to really push the envelope, and using the definition that we used earlier, we really want to be excellent and team with others to be excellent at additive manufacturing, and not just be good at it. So because of this, we are targeting building larger pieces, larger sizes. We saw an auto body this morning. We'd love to build something bigger than that. Looking at using more advanced materials in AM, understanding the process control and the feedback with respect to this type of manufacturing, and also all the things that are related to any of our other products, understanding the reliability, understanding the producibility, understanding how to maintain these items. A very important part of what we do as a large-scale integrator is understanding what our factories need to look like. And this is the gist of manufacturing for us. We can fabricate parts, but how do we join them together? And I saw some excellent booths that describe exactly what the future of manufacturing needs to be for aerospace engineering. We understand what it used to be. As you can see here, today we are integrating automation where we can and understanding the needs. And also we are simulating what the future needs to look like. We're using a lot of simulation today, but I think the big step for aerospace or for any other industry is understanding how can automation best be used. Right now we're looking at how can we use it in the factories that we have today. For the future, we need to design the factories and the build systems, and actually even redesign the parts so they can utilize all of the advantages of automation for the future. So this is just a life cycle or value stream, if you will, of what we go through in the design of any of our products. And this is very typical probably for many of you as well. We start at understanding the materials in the lower left-hand corner, understanding the materials very well, what they can do for us, how they will behave in certain environments, what advantages they give to us, and we make certain decisions based on those. As we move through the life cycle of development, we understand how we need to fabricate these things. We go through various technology maturity levels with the materials and the fabrication process themselves so that we can optimize and filter out the things that will not work for us. Finally, we understand what, we do computational modeling to determine what the future could look like, how we might utilize these to make actual parts for our products. And then we take that and build it into, also model it and start to build prototypes of the subcomponents. And finally, and at that point, we decide how will we actually fabricate these parts. We've used some of the tools that you've heard about before to understand, is it a make or a buy, or is it something that we should design differently? And finally, we get to full-scale testing and prototyping, first prototyping testing, full-scale testing of the product. So the opportunities for us are innovation, where we need innovation, is materials by design. First of all, going back to that first part of starting with materials, can we design the materials and can we take advantage of this, what we know from nature, from the materials that we have today, and do better designs? And we're actively working on that through simulation and testing of prototype or specimens at this point. How can we tailor laminates for the composite materials so that we can certainly take advantage of these properties? There's been a habit, and many of you who may work with composites or non-metallics may understand this very well. People tend to make things, if they've used them in one form, such as metal, they tend to make the composite parts look like metal as well. So how do we really take the advantage of the material systems themselves and redesign and change our mind of how we redesign? How can we also eliminate certain types of production activities such as fasteners, because it'll save us weight and save us time, and also save us some of the inspection that we have to do with these particular assemblies. And then the advanced assembly technologies is something that we cannot underestimate, because as a major integrator, or having our primary duty as integration of primary structure, we do have to pay attention and take advantage of the technologies that are out there. So our challenges are focusing on the needs across the full life cycle of any product, from the materials development to the final product delivery, and then even beyond that, what are the services that we have to provide? How do we assemble all of these? What are the make-buy decisions we have to do? How do we work with our partners and suppliers to get new innovations on the product or in the product floor? We have to look at multiple products. As I said before, that's a huge challenge for us, because somebody mentioned it this morning, you don't want to just put a lot of money into a niche product. However, some of our products are very demanding in what they need. So how do you manage your portfolio so that you have spend the proper amount of money and development on each of these? We need faster development cycle time and controlled development costs. That's a major initiative for us. There was a DARPA study that showed that the cost of developing products in aerospace had increased exponentially over time, while in the automotive industry it actually decreased over time. So we've been studying a lot of technologies and business models, if you will, as to how to approach this so that we too can try to get our cost under control for development. We need a smooth transition to production, whether it's on the production floor or on the product itself. We encounter, as everybody else does, that valley of death where we've developed something and how do we get it to the next TRL level so that it actually gets captured on the product or in the production area. We need architectures that exploit the material and processing characteristics as well as the assembly technologies, and we have to use these smartly. And once again, I think in the industry in general, we need a reversal of thinking and looking at the actual manufacturing technologies and then developing our products and redesigning them to take advantage of these. And we need, very importantly, we need global partnerships. If you asked me 15 years ago if Boeing was a global company, people would have disagreed with me, but I would have said no. We were a US company that sold things overseas. We've become more global because of the 787. We have parts made in multiple countries and major structures as well, and there's design authority in many of these areas. We've spread out across the US because we're trying to capitalize on capability as well as the capacity to do the work that's needed. And you'll see us do more and more of that because we do need that capacity and capability. Once again, I mentioned before, we have to take care of our research portfolio, and every company has to deal with this very, very strategically. It's not an easy thing to do. None of us are in single point markets. We have to increase the use of modeling tools and understand what they really mean. In the past, it was a nice thing to do. Now we have to really incorporate this into our design policy. We need to promote lean thinking. This goes to the cost issues that I mentioned before. We're trying to drive down our own cost as well as we develop our new products. Fully integrating our design so that we can come about with breakthrough architectures by taking advantage of the materials and the manufacturing technologies as much as we can. And then we have to improve the robustness of each of these technologies as it applies to our particular field. We have to engage our partners and suppliers in development and validation as well. This is a very important thing to note, and we've started doing more of that because they understand the technologies often as well as we can. As we've become more global, a lot of our R&D is not done within the four walls of Boeing. We look for good technology and development throughout the world, and we need to really make sure we develop a culture, the ecosystem that people pointed out this morning, that allows the companies to really show us what they can do in terms of capability, and then let them take the lead on helping us as much as they can. Developing future leaders and specialists. I can't emphasize this enough. I like the discussion people have had about developing the future workforce. And I like the last presentation where the foundational block, just the skills area. The comment earlier today that do we even understand what we will be needing for the future and to lead these manufacturing technologies. I truly believe that we don't understand it today, but we have to work together to define it well, understand where it needs to go, and really put some emphasis on developing the future workforce. So in summary, I showed this chart at the beginning showing the evolution of where we've been, where we've come from in terms of a very hands-on, very fundamental materials development and build, both design and build area, to the tools that we're using today. But also, we aren't there yet. There's more to be done, and I'm very pleased to be at a forum like this where we can have the kinds of discussions and learn from each other. That's it.